All right, let's look at the homework 15.10, problem number 8. All right, so let's evaluate this double integral using change of variables. All right, so let's see. If you look at this expression in the integrand, you can see we have a y minus x and x plus y plus x. Maybe I'm going to try this. I'm going to let u to be y minus x and let v to be y plus x. All right. Then I'm going to just translate this into uv points. So here, all right, so we have, let's say u comma v is, all right, so first point, u is y minus x, so it's going to be negative 2, and the v is the sum, so it's a negative 2 comma 2. Alright, so next point is, let's see, 0 minus 9, so it's going to be negative 9. And the sum of these two, so it's going to be 9. Right, third point is going to be subtract, so you have, let's see, 9 minus 0, so it's a 9. And v is going to be 0 plus 9, so it's 9. And the last point is 2 minus 0 is 2. And add them up, so it's 2. So those are the corner points. All right, so I'm going to just draw the region here. So it's going to be here. So this is going to be our u-axis. And I'm going to say this is going to be our v-axis. All right, so first point is negative 2 comma 2. So let's put the negative 2 here and the positive 2 right there. So we know that the point is going to be right here. All right, so that's at negative 2 comma 2. And the next point is negative 9 comma 9. So negative 9, I'll probably put it right here. And it's going to be 9 up here. So the point is going to be negative 9 comma 9. So the point is going to be up here. All right. Then 9 comma 9. So we have, let's see, 9 is probably around here. And you have a 9 already there. So this is our third point. All right, so we have that. This is our third point. And the last point is 2 comma 2. So it's going to be 2 right here. And the 2 is already there. So we have, all right, so we have that. Alright, so we can just connect them all together. So we have connect those guys together, connect those guys together, and connect those together, and connect those together. Alright, so we have this region here. So this is the new region in the UV plane. Alright, so let's set up integral here. All right, so this is going to be, so the integral is going to be equal to, right, we put the double integral here. All right, oh, I forgot to do the Jacobian, so let's do the Jacobian first. So before we do that, let's find the Jacobian. Since this equation is written u equals and the v equals, I'm going to go ahead and find the reciprocal of the Jacobian that we want. So partial of u comma v with respect to x comma y, right? So partial of u with respect to x is going to be negative 1. Partial of u with respect to y is positive 1. Partial of v with respect to x is 1. Partial of v with respect to y is 1. right? So this is going to be negative 1 times 1 is negative 1, minus 1 times 1 is 1, so it's equal to negative 2, right? So which means that if we want to find the Jacobian x comma y with respect to u comma v is simply reciprocal, so it's going to be negative 1/2, right? But since we're taking the absolute value of the Jacobian anyway, so this is going to be just 1/2. All right, now we can set up the integral. All right, so the integral is going to be equal to, so I'm going to go down here. All right, so we set up a double integral. All right, so you have a 7 cosine of 7 times. All right, so we decided to call y minus x u, so it's going to be u over v, right? Then Jacobian, absolute value of Jacobian is 1/2. And then we can probably say, let's see, I'm going to do v first. Let's do a dv first, a dv and du. All right, so for fixed, let's see. Oh, actually, I want to do the other one? Yeah, I want to do the other way, sorry. So I want to do du dv. All right, so you can see that for fixed v, right, in order to go from, to cover that, you have to go from there to there, right? The equation of this is actually, so it's just the slope is negative 1, right? So this is going to be a v equals negative u, or maybe I should say u is equal to negative v, same thing, right? And this one is u equals v, right? So we're going from u equals negative v to positive v, right? Then we can start from here, so v is equal to 2 all the way to v equals 9. So we're going to go from 2 to 9, right? So we got that. All right, so I guess first thing I would do is I'm going to just take this is just a constant, and that's a constant. I'm going to kick them out of the integral. So I'm going to just put the 7 halves outside and leave the outside integral as it is for now, so dv. All right, so we want to find the antiderivative. So antiderivative cosine is going to be a sine of 7u over v, right, divided by, right, derivative of that with respect to u would be 7 over v. So you have a 7 over v, right? Then it's going from negative v to positive v, right? So this is going to be equal to, right, 7 over 2 is outside, integral from 2 to 9, right? 7 over v, so it's a reciprocal, so it's a v over 7, right? Then if you plug in v, so you have a sine of 7. So you have a sine of 7, right? Maybe I'll just do that. Minus, and plug in negative, so it's going to be sine of negative 7, which is equal to the same thing as positive sine of 7. Right, so you have 2 of those guys. So we have 2 of those, and you have 1/2 here. So I'm going to just cancel with this guy and 2 of those and cancel 1 of them. All right, so we got that, and also actually there's a 7 on top and 7 on the bottom, cancel out. All right, so what you get is sine of 7 is just a number, so I'm just going to put it outside, sine of 7. then anti-root of v with respect to v would be v squared over 2, and then going from 2 to 9, right? So this is going to be sine of 7, plug in 9, so you have 81 over 2, minus 2 plug in 2, so it's going to be 2, so it's going to be just a 4 over 2. So this is going to be, let's see, 81 minus 4 is 77 over 2, and the sine of 7. All right, so let's type it in. So we got 77 over 2. Then we have a sine of 7. All right, so let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.